Hello mga ka-tribes! Welcome to Daddy Brew TV. Okay, for today's video, let's have general mathematics test. The question is, determine the domain and range. Example number 1. The given is f of x is equal to x minus 5. Now, for our solution, since y is equal to f of x, then we will rewrite the given f of x equal to x minus 5 as y equal now to x minus 5. And then, to find the domain, let us solve y or rewrite y in terms of x. Take note that the given function, when written as y, the equation is a polynomial function. Okay? X minus 5 is a polynomial function. So therefore, there is no restrictions. And then, of course, the domain is all values of x such that x is an element of any real numbers. Now, what about for the range of the function f of x is equal to x minus 5? Okay, again, let us rewrite y equal now to x minus 5. Solving for x in terms of y. So we will use our knowledge of transformation here. So transposing negative 5 to the left, we have y plus 5 is equal now to x. And then let's interchange. X is also equal to y plus 5. Take note that the equation x is equal to y plus 5 is also a polynomial function or equation. So then, there is no restrictions. So of course, the range is also all values of y such that y is an element of all real numbers. Okay? Example number 2, the given function is y is equal to 1 over x. So again, to solve or to define the domain, always see to it that the equation must be solved y in terms of x, or must be written as y form. Okay, for our solution, take note that the given y is equal to 1 over x is already into a y form. So for an equation y to be real, the denominator x cannot be equal to 0. Okay, now y, let's try to check. Now, if x is equal to 0, let's replace x equal to 0. What is 1 over 0? No answer, right? Meaning it is not a real number. So it is undefined or infinite. Okay? Undefined. So that's it. So therefore, the domain of the function y is equal to 1 over x is all values of x such that x is not equal to 0. Okay? Now, what about the range? Okay. To determine the range, again, the given is y over or is equal to 1 over x. So to determine the range, let's rewrite or solve for x in terms of y. Okay? So solution. So this is bring down y is equal to 1 over x. Now let us cross multiply. This one is over 1. So what is x times y? That is xy. What is 1 times 1? That is 1. Then, let's solve for x. So, let's divide this by y, both sides. So, we have now x is equal to 1 over y. Now, take note of the given equation x. For equation x to be real, let y not equal to 0. Okay? Again, if y equal to 0, let's solve 1 over 0. It is also undefined. So therefore, the range of the function is all values of y such that y is not equal to 0. Okay? Now, let's have example number 3. The given is the function f of x is equal to 1 over x minus 1. So again, to determine the domain, always write the equation y in terms of x or solve for y in terms of x. Okay, solution. Since y is equal to f of x, so let us rewrite our given as y is equal to 1 over x minus 1. Take note that the given is already into y form. So for y equation to be real, let x minus 1 not equal to 0. Okay? So x minus 1 not equal to 0. Okay, let's solve for x. So therefore, x now is not equal to positive 1. Okay? Now, let's check our answer. If x is not equal to 1, let's substitute. Say, replacing x equal to 1, we have 1 minus 1. So that is now 1 over 1 minus 1 is 0. So again, 1 divided by 0 is undefined or infinity. So therefore, the domain of the function is all values of x such that x is not equal to 1. Okay? Next, what about the range of the function? Now, to define the range, again, rewrite the given into y form. That is, y is equal now to 1 over x minus 1. Now, to solve for the range, of course, take note that let's solve for x in terms of y. Okay? Always rewrite the equation into x in terms of y. Now, let's cross multiply. This is over 1. So if we cross multiply, we have y times x minus 1 is equal now to xy minus y is equal now to 1 times 1 is 1. And then solving for x, we have xy is equal now to positive y plus 1. So we transpose negative y to the right, so it becomes positive y. And then solve for x, so divide both sides by y. So cancel this out. So we have now the equation x is equal to y divided by y is equal to 1. Then 1 divided by y is equal to 1 over y. Or you can also rewrite this as x is equal to 1 over y plus 1. Now, for the equation x to be real, let y not equal to 0. So y must not be equal to 0. So let's check. If y equal to 0, let's see. So what is 1 divided by 0? So that's undefined. Okay? So therefore, the range of the function is all values of y such that y is not equal to 0. Now, let's have example number 4. The given is y is equal to the square root of 5 minus 2x. Now, to determine the domain, let us solve for y in terms of x. But take note, the defining equation y is equal to the square root of 5 minus 2x is already expressed for y in terms of x. Since y is a radical, y must be greater than or equal to 0. And therefore, its radicand 5 minus 2x must be greater than or equal to 0. Then, let's solve for x. Bring down minus 2x, transpose 5 to the right, and that is now greater than or equal to negative 5. Now, if we divide both sides by negative 2, since we're looking for x, then the symbol of inequality will change. This is cancelled out, so we have from greater than or equal to, it will be less than or equal to. Then simplify negative 5 over negative 2, that is positive 5 halves. Take note, if you multiply or divide the relation or inequality relation, the sense of inequality will change. That is why it becomes less than or equal to. So therefore, our domain is all values of x such that x is less than or equal to positive 5 halves. And that's the domain. Okay? Next, what about the range? Now, to determine the range, let us solve for x in terms of y. Okay? So, the defining function is y is equal to the square root of 5 minus 2x. So, let's solve for x in terms of y. Now, let's square both sides. Okay, so y squared, that is now equal to y squared. This is cancelled out, and then we have 5 minus 2x. Since we are solving for x, let us transpose positive 5 to the left. That will be equal to negative 5. Is equal now to, we will bring down negative 2x. Let's interchange this. So it becomes negative 2x is equal now to y squared minus 5, because we are solving for x in terms of y. Now, to solve for x, let's divide both sides by negative 2. Okay, so cancel this out, we have x is equal now to, the coefficient of y squared is 1, positive 1, right? So positive 1 divided by negative 2 is negative 1 half y squared, and negative 5 divided by negative 2 is positive 5 halves. Now, our equation x is a polynomial. Okay? So therefore, the range is greater than or equal to 0, or the range is set of values of y such that y is greater than or equal to 0. Now, why greater than or equal to 0? Knowing that the equation x is a polynomial, because in the original equation, y is equal to the square root of 5 minus 2x, the restriction must be greater than or equal to 0. Okay? Thanks for watching. See you on my next video. Bye!